And parallel lines have specific properties. I think some of these are going to seem familiar to you. So hopefully we can all see this picture. Okay, it's a picture, a theoretical picture of some street map in Florida. Okay. The question that I want you to is, you can see all the angles that are numbered, right? 1 through 12. I want you to determine with your group, and I'm going to give you about 2 minutes to do it, all of the different pairs of of congruent angles. So there are a lot of them. So I want you to determine all of the different pairs of congruent angles and try to justify why you think they are congruent. Okay, I'm going to give you about, let's say, 2 or 3 minutes to do that. Okay, the picture's up here in front of you. In your group, I should hear lots of conversation. I want to know all of the congruent pairs of angles and why. Count up the number of pairs of angles that you found to be congruent, and I want to know how many each table found. Okay, so count them up real quick. How many you found that were congruent? Okay, who found at least 6 pairs of congruent angles? Okay, who found at least 8 pairs of congruent angles? 10 pairs of congruent angles? 12 pairs of congruent angles? 14 pairs of congruent angles? How many did you guys find? 17. How many did you guys find? 14? Okay, let's talk this through then, okay? So, make sure that we're paying attention. We're just going to go through the room and you give me a different pair of angles. So starting with table 9, what's one of your pair of congruent angles? Okay, 1 and 3. How do we know they are congruent? They are vertical angles. Okay, good. Table 8, what's another pair? What's that? 2 and 4 for the same reason, right? Okay. Table 7, what's another pair of congruent angles? Okay, so let's get all the vertical angles out of the way then. Okay, so vertical angles there. Okay, I'm going to use, since I'm using red, we'll just go back to 1 marking, and then 2 here and here, and those ones, right? So those are all vertical angles, right? So that's 6 pairs of angles. So table 6, what's another pair of congruent angles? 11 and 5. Okay, do you know what we call these angles? We call these angles alternate exterior angles. Good, right? So if 11 and 5 are congruent, what other 2 angles have to be congruent by the same logic? 6 and 12, right? These ones right here are alternate exterior angles. Okay. Table 5, give me a different pair of congruent angles. Okay, what do we call those? Alternate interior angles, right? And if 8 and 10 are alternate interior angles, then what are the other pair of alternate interior angles? 7 and 9. Okay. Table 4, give me another pair of angles that you guys found to be congruent. 10 and 6, do you know what we call these angles? We call these corresponding angles. So 10 and 6, okay? And now we're going to get a few more, right? Because that means if 10 and 6 are, then also 5 is congruent to what? 9 and 8 is congruent to 12, and 7 is congruent to 11. Okay? Are there any others that we've left out? Were there others, or did we just miscount? Okay, so 14. Okay, so I believe 14 is what I found also. Hopefully everybody picked up on this. We can't use corresponding angles. Like, why aren't we saying that 3 is congruent to 7? Because the lines aren't parallel, right? So this is the key thing here, right? The fact that the lines are parallel is what makes all of those things true, right? So we're going to talk about our different types of angles. So first one here, okay, it's one that we haven't even talked about yet. It's called the same side interior angle postulate, okay? So this should be in your paper, okay? What this says is if a transversal intersects 2 parallel lines, then same side interior angles are supplementary. Okay, let's remind ourselves, what does it mean to be supplementary again? Adds up to 180, right? Okay, so if a transversal intersects two parallel lines, then same side interior angles are supplementary. So in this picture on this book, 4 and 5 are same side interior because they're on the same side of the line that cuts across the parallel lines, the transversal, and they are inside of the parallel lines. So same side interior, they're going to be supplementary. By the same logic, 3 and 6 are also same side interior angles, right? They're on the same side of the transversal, the one that cuts across the parallel lines, and they are inside of the parallel lines. Okay, so they are supplementary. I find that we know the things about congruent. Sometimes we start to make these congruent, and that's where we start to have some issues. Okay, so let's just practice with this a little bit. If angle 3 is 55 degrees, okay, I want you to determine all of the angles in this picture that we know are supplementary to angle 3 and what their measure is. Okay, so which angles are supplementary to angle 3 and what is their measure? Okay, I'll give you about 2 minutes. Okay, ready to go. What are the angles that are supplementary to angle 3? So angle 2 is supplementary. Can somebody else tell me why angle 2 is supplementary? What do we call angle 2 and angle 3? Not adjacent. We call them a linear pair. They are adjacent, but the reason we know they're supplementary is because they make a linear pair. Okay, table 1, what's another one? Angle 4, by the same logic, right? It's also a linear pair. Okay, what's another one? Okay, well, before we get to 6, what's the other one? Because we need to know something else first, right? 8. If 8 is supplementary, how do we know 8 is supplementary to angle 3? Somebody else tell me. Charlie? They are same side interior angles. So they also said 6 was. I want somebody else to tell me why is 6 supplementary to angle 3? Kaylee? Yeah, so you're saying we know 6 is the same as 4 because they're alternate exterior, right? We could use a bunch of things that way, right? Because we also know 6 is the same as 8, right? Because of vertical angles. So either one of those would be good. We also know 6 is the same as 2 because of corresponding angles, right? We haven't talked about that theorem yet, but we will, okay? And so we know that that's the case. Table 2, what's the measure of all of those angles? Individually. 3 is 55, yes. What's the measure of angle 2, angle 4, angle 6, angle 8? 125 degrees, right? Okay, because if it's supplementary, it's adding to 180. Okay? All right, let's see here. Oh, I didn't want to do that. Okay. In your groups, I want you to identify all the angles that are congruent to the 51 degree angle. I'll give you about a minute or so. All the angles that are congruent to the 51 angle. Okay, class, let's see. Table 1, I think yours are the only ones I haven't quite picked on yet. Table 3, my bad. Table 3. Which angles are congruent to the 51 degree angle? 7, 4, and 5, okay? Why? Why is 7 congruent, class? Why is 7 congruent? Vertical angles. Why is 4 congruent? Alternate interior angles. And why is 5 congruent? It's alternate exterior with 7, but it's also corresponding to the 51 degree angle, right? Okay. Okay. Now, let's see here. Okay, this is the alternate interior angle theorem. It says the alternate interior angles are congruent. We seem to know that already. This is also on your pink sheet. Okay. This is the corresponding angle theorem. Okay, it says that if you have two parallel lines, then corresponding angles are congruent. Okay, just to get an idea of the practice of this. Okay, if we assume, class, if we assume that all of your desks are making the same grid, okay, everybody who would be in a corresponding seat to Ellie, raise your hand. If you are in a corresponding seat to Ellie, raise your hand. A corresponding seat to Ellie, raise your hand. Yeah. So, all the people who would be corresponding are in that same spot, right? So, Savannah, Charlie, Sophie, Bridger, Cooper, Haley, and Maddie. Okay? When they are across, they are vertical angles. Corresponding, class, the reason I do that is because the best way that I found to remember what corresponding angles are is they are angles that are in the same place at the intersection, right? So when we look at this, angle 1 is upper left angle, and the same one is angle 5, right? It's in the same place at that intersection, okay? So that's what corresponding is, right? That's the only one that's a little bit different, okay? Okay. So right here, we're going to go through and look at a proof for the alternate interior angles theorem. A lot of times we will have information like this. It'll say angle L is parallel to angle M, and prove that angle 4 is congruent to angle 6. Now, anytime we ask you to do a proof, and you go, well, that's obvious because it's alternate interior angles, that's probably not what we're trying to get done, right? We're not asking you a question for you just to say in one line alternate exterior angles or alternate interior or whatever. We want you to prove that that theorem is actually true or valid, okay? So we can't use the theorem here because we're trying to prove that theorem, okay? So here's our proof. I want you to talk it out with your group and fill in the blanks, okay? I'm going to give you about a minute or so. I want you to fill in the blanks with your group, okay? Ready to go. Let's talk about it then, okay? Now, this first statement right here, we know that it's going to use something about supplementary angles, okay? And we see down here that we're going to have the transitive property. So my guess is that we probably need something in here that's going to say something is equal to 180. And so I'm going to say that measure of angle 3 plus the measure of angle 4 equals 180, right? Now we know that that's true because they're a linear pair, they're supplementary, so that's what it means when we say that they're supplementary angles. So what's our reason for this line 3? Our reason here should be the same, that they are same side interior angles, right? Okay, we have angle 3 and angle 6 are same side interior, that means they're supplementary, okay? Now, the transitive property, remember, the transitive property says that when two things are equal to the same thing, then they are equal to each other, right? Both of these things are equal to 180, which means my next line will be measure of angle 3 plus measure of angle 4 equals measure of angle 3 plus measure of angle 6. Okay, and then how do we go from line 3 to line 4? Subtraction property of equality. Okay, right there. Okay, now that process that we just went through is really similar to what you'll need to do on a quiz. So you'll go through and you'll have these fill in the blanks that you're going to fill in the properties or the statements as you go through a proof. Very rarely will we ask you to create an entire proof from scratch, although there is one on the quiz whenever we have it where that is that way, but it's algebraic, so it's a little easier to come up with the statements there. Kaylee? At the end? Yes. No, but we are proving that theorem. So we can't prove that theorem by stating that theorem, but not by you. So now you're proving it. Okay. Also, on a quiz, there'll be a certain number of lines that we expect you to fill in, right? And so that's how that'll go. Yeah, it'll be fill in the blank normally. Like it'll be like really similar to what you just saw. You won't be coming up with the entire proof. Okay, we're going to skip this one in the interest of time. Okay. Okay, class, let's talk about this one together. Okay, let's assume for a minute that we did want to create a proof from scratch. Okay, this says assume that that line A and line B are parallel. It wants us to prove that angle 1 and angle 8 are supplementary. Okay, so if I were making a proof for this, I would start with, statements and reasons. Okay, my first statement would always be my given statement, so A is parallel to B, and the reason is always that it's given to us, right? I don't know that I've said that enough as we've talked about proofs. Your first statement should always be your given statement, and your first reason should always be because it was given to you. Okay, so A is parallel to B. So if I know A is parallel to B, we can't use alternate exterior angles because we already know that that's the case. Okay, we need to figure it out a different way. So I know that I'm trying to get to 8 is congruent to 1, right? And actually, sorry, 8 and 1 are supplementary, my fault. So what I would say instead, okay, is probably I would start with this. The measure of angle 5 plus the measure of angle 8 is equal to 180. Okay, what would be my reason for saying that? They are supplementary. Why do we know they're supplementary? They are a linear pair, right? So linear pair are supplementary. Okay. Now, I'm also going to state in here, class, that the measure of angle 1 is congruent, or is equal to, sorry, my fault, equal to the measure of angle 5. Okay. What theorem am I using in order to say that? Corresponding angles, right? So I'll just put corresponding angles. Okay. Now, what can I do to this equation using this statement to get it so that I'm getting somewhere more productive? I'm trying to show that 1 and 8 are supplementary. So what can we do next, Cassidy? Yeah, we can use substitution. And what am I substituting in particular? Yeah, we know angle 1 is equal to angle 5, so I'm going to substitute it into my equation. So measure of angle 1 plus measure of angle 8 equals 180. And again, Cassidy already said we did that by substitution. Okay. Now, I'm not quite done yet, right? My final statement was that angle 1 and angle 8 are supplementary. Okay, so if I state that now, angle 1 and angle 8 are supplementary, what would my reason for being able to state that be? Yeah, the definition of supplementary, right? We said that the two angles added up to 180. So if we now have that there, we can use the definition to say that they are indeed supplementary. Okay? This is the idea of what it would look like for us. Okay, in a full proof. All right, let's see. We're going to go like this. Okay. We're also going to skip this, partly because we have some other stuff we need to get to. Okay. Okay. Sorry, we're skipping a few things here. Okay, I do want you to do this one, page 420, or it's in page 425. You don't have your book out. Okay, here's your picture. Okay, class. In the figure below, I want you to determine the values of x and y. Okay, now the only reason we should be able to do this is because we know that these two lines are parallel to each other. Because we know they are parallel, that should help us figure something out. So I want you to figure out the measure of x and y. Okay, you have about 2 minutes or so to do that. Okay, ready to go. Class, What do we get for x? X equals 64, which means this angle is 128 and this angle is 52. Okay. Class, what do we get for y? 40, which would mean this angle is 120 and this angle is 60. Okay. Class, what does this tell us has to be true about quadrilaterals and their angles, by the way? They all add to 360. Okay. They have to add up to 360 in a four-sided object. Okay. All right, let's see. All right, one more section of material that we need to cover. Okay. Yeah. So, now what we are going to do for the rest of today, and hopefully I think we should be able to get a pretty good handle on this, and then between that and your homework, you should be pretty prepared for the quiz tomorrow, so we'll be in good shape, is we are going to work backwards. All the theorems we just talked about depend on lines being parallel. Okay? So what we're going to work now backwards, how we're going to work backwards now, is we are going to take information about angles and prove that lines are parallel, that certain lines are parallel. Okay? So we have some other theorems to get in. Okay? Before I really get into this theorem, we need to understand kind of mathematically what the word converse means. Does anybody have an idea or is familiar at all with that word converse? All right, let me give you an example. Okay, in math statements, right? When we're proving things, we use a lot of if-then statements. Okay, so class, for example, if we say these two lines, if these two lines are parallel, then alternate interior angles are congruent. Or if these two lines are parallel, then corresponding angles are congruent. A converse flips the if and the then. Okay? So, when you are making another statement, let's say, okay, let's just say it like this, right? If it is raining outside, then the grass is wet. Okay? Right? If we were to flip that statement around and say it's converse, we would say if the grass is wet, then it is raining outside. Now, is that 100% true all the time? Not necessarily. So not all converses are true. Okay? Now, it could be true, but it also could have just been sprinklers or morning dew or anything like that, right? Could have been any of that. Okay? Now, in math, when we make a converse statement, most of the time, and really in this class, converse statements will be true. Okay, so the converse of corresponding angles theorem works backwards. It says that if we have angles, corresponding angles that are congruent, then the lines that created them must be parallel. Okay, so you have to think backwards on this. That takes a little bit of effort for us mentally sometimes. Okay, so if I know that angle 2 and angle 6 are congruent, then I know that line L and line M are parallel. Okay, so we're using the same theorems, but whenever we say converse in front, and this is really the big takeaway from today, from this part of today, if we're saying converse of something, we're proving that lines are parallel. If we are using just the normal version, so if we were saying the corresponding angles theorem, that what we're doing is proving that angles are congruent. Okay, so converses prove things about lines. The other theorems prove things about angles. Okay, so converse of corresponding angles theorem says that if we have two corresponding angles that are congruent, then the lines must be parallel. Okay, so let's look at this for a moment. We'll just talk through this. If I know that angle 1 and angle 2 are congruent, so angle 1 is congruent to angle 2, okay? Then which two lines do I have to know are parallel? A and B, right? They're the two that created those corresponding angles, okay? Now, let's make sure. Why would it not be L and M? Why wouldn't L and M be the two that would be parallel based off of 1 and 2 being congruent? Gracie. Yeah, 1 and 2 are both touching M, but neither of them is touching L, right? So they have nothing to do with L. For all we know, L could look like this, okay? Now it doesn't look like that, but it could look like that, right? Okay, so let's see. Oops. Okay, I want you to think this through on your own. If angle 6 and angle 7 are congruent, I want you to determine which lines must be parallel. Okay, so think it through on your own. We'll answer all together here in a moment. Probably. Okay, so class, what do we think? If 6 and 7 are congruent, 6 and 7, which lines are parallel? What was that, Sophie? L and M, right? Because those are the two lines that are intersecting with 6 and 7. Okay? All right. Okay, what about this? Okay, I want you to think through it again on your own. This angle is 45 degrees, this angle is 45 degrees. Based off of that, which two line segments are parallel to each other? Okay, I'll give you about a minute or so to think it through. Okay, class, this is for everybody, so please respond. Okay, if these two angles are congruent, which choice is correct, A, B, or C? A, so we're saying that CA is parallel to HR. Do we agree? Yeah, okay, I agree. Okay, good. So let's look. Okay. Now, there are other converses. All we've done so far is look at the converse of corresponding angles theorem. And really, we could put converse in front of any of our theorems and then make sense of it, right? But the ones that we'll focus on right now is the converse of alternate interior angles. So what this says is that if you have alternate interior angles that are congruent, then the lines that make them must be parallel, okay? Converse of same side interior angles, okay? And what this is saying is that if you have two same side interior angles that add up to 180, and the lines must be parallel, right? They're always going to get back to the lines must be parallel if that's the case, okay? And then converse of alternate exterior angles. So if you have alternate exterior angles that are congruent, then the lines that form them are parallel, okay? Now, really what I care about is not so much that you know the theorems as much as that you can use the theorems. Okay, that's a proof of the alternate interior angles. What I want you to do in your group is fill in the blanks on this proof, okay? Now, we're trying to prove our last line here is that line L is parallel to line M, which means you will need to use a converse to do it, okay? So, talk it out with your group. I'll give you about a minute or two to do so. Done, so let's check this out and see what we get here. Okay, our first statement should be this angle 1 is congruent to angle 7. That's our given statement. Our reason for it is given. Okay, class, how do we know angle 1 is congruent to angle 3? Angle 1 is congruent to angle 3 because they are vertical angles. Okay, how do we know angle 3 is congruent to angle 7? Transitive property of congruence. And then by saying that angle 3 is congruent to angle 7, which converse will we use to prove that the lines are parallel? We will use the converse of corresponding angles. Okay, so right here, here's how I would keep track of that. The last statement that I made before my parallel line statement was that this one was congruent to this one. So then I just look at what type of angles those are. So those angles are corresponding. So that means we're using the converse of corresponding angles. Okay? This is the sort of stuff that you're being asked to do on your quiz. Okay? All right, let's see. We're going to skip that one. And that one. Okay. Well, yeah. Okay, all right. So right here, class, this looks a little different. It's a flow chart proof, a flow proof. Right here, this A is the reason for this statement. B is a statement that would go with this reason, or D is. B is a statement that would go with this reason. C is the reason that would go with this statement. And E is the reason that would go with that statement. So it's always statement, reason in a flow proof. Okay. This will be the last thing we do. I need you as a group to fill in the blanks. Okay. A through E, decide what it is that should go there. Okay. Whoops. Okay. Class, focus here, please. Okay. What's our answer? What's our reason for A? Given. What's our statement? What's our statement for B? Anybody get this? Carter? The measure of angle 1 plus the measure of angle 2 equals 180. Okay. What about C? What's the reason for C? This is the definition of supplementary. Okay, class. What is the statement for D? Angle 2 is congruent to angle 3. Now look at our flow proof, right? They both are saying that angle 1 and 2 are supplementary, and angle 1 and 3 are supplementary. So, right, if two angles are supplementary to the same angle and they are congruent to each other, we talked about that yesterday. So right here, angle 2 and angle 3, what type of angles are those? Corresponding. So which converse are we using at the bottom? The converse of corresponding angles. Okay, we have a quiz tomorrow. All of your homework is on Math Excel. Yep.